Okay, he has given 4 options. We have to choose correct options out of these 4. Okay, the triggering pulse to main terminal should be of the same polarity as the anode potential between MT1 and MT2. If you see in triac, okay, let us draw the symbol for triac first. Triac is nothing but an anti-parallel connection of thyristors. Okay, I can draw the shape of triac as this is anode, cathode, and there will be a gate terminal G, or simply I can write this one as anti-parallel connection of thyristors is nothing but triac. Okay, I am representing this one as MT1 and this as MT2, thyristor 1, thyristor 2. Now see the first option here, the triggering pulse to main terminal, that is this gate 1, the triggering pulse to main terminal should be of same polarity as the anode potential between MT1 and MT2. What is anode potential here? This is the anode 1, this is the anode 1 and this is the cathode 1. Similarly, this is anode 2 and here we have cathode 2. So first option is absolutely right. Now look at the second option here, second one here. The triggering pulse should be opposite polarity to that of anode potential. Okay, this is wrong because it should be of same polarity as he has given in first one. Okay, now look at third one here. When the triggering pulse is positive and anode is positive, it is operating in the first highest. What does it mean? That when gate is positive and that is triggering pulse is positive and anode is positive, it is operating in first quadrant. Okay, the thyristor at which triggers, it is called as first highest point. Okay, so third one is also right. Now look at fourth one here. When triggering an anode voltage is negative, sensitivity is highest. Okay, sensitivity defined in 2 quadrants here, since this triac will operate in first quadrant and third quadrant. Okay, when you talk about first quadrant, when triggering pulse should be positive and anode voltage should be positive. If you talk about third quadrant here, triggering pulse should be negative. Similarly, anode voltage should be of negative. Only at these two instances we have highest sensitivity to this triac. So fourth one is also right. So option C is correct answer. Single phase full wave SCR circuit with RL load. Okay, now he has given 4 options here. The first one is power is delivered to source for delay angles of less than 90 degrees. If you see for alpha less than 90 degrees, power is delivered to the load. For alpha greater than 90 degrees, power is delivered to source. So option A is false. Now look at option B. The SCR changes from inverter to converter at alpha equal to 90 degrees. Okay. For alpha less than 90 degrees, the circuit will behave as rectifier. For alpha greater than 90 degrees, this will behave as inverter. So option B is also false. That means we have to find the true statement out of these 4 options. Now look at option C here. Negative DC voltage is maximum at alpha equal to 180 degrees. This option is absolutely true. Okay, now this rectifier action will change to inverter when alpha equal to 90 degrees. Now at alpha equal to 180 degrees, we have maximum DC voltage, that is as negative. Okay, at alpha equal to 0, we have DC voltage totally is positive, that is maximum voltage across the output is positive. Okay, option C is true. So answer is option C.
And g of z are the one-sided z transforms of discrete time functions f of nt and g of nt. The z transform of summation of f of kt g of nt minus kt is given by. See from the above given expression, that is sum of f of kt g of nt minus kt is nothing but the convolution of two functions f of nt g of nt. If it is in time domain, if it is convoluted, then it is in frequency domain or in z domain, it is going to be, if we apply the z transform, it is going to be f of z and g of z. According to this one, hence option, according to this one, if we take the z transforms of individual functions f of nt and g of nt, if we multiply those things, we will get option B as the correct option.
In UJT relaxation circuit, output is applied to SCR. The shape of the waveform is. Okay. Now, if you see in UJT relaxation circuit, the characteristics for UJT, that is unijunction transistor, is, it will be like this. Okay, this is called peak point and this is called valley point. Now UJC will conduct only when it reach its peak point. Okay, and it will turn off when the voltage point is equal to valley point. That means the output waveform will be like this. Okay, if you see here output waveform, these signals are very short duration of time it is present, and these pulses are very sharp. You can treat this one as impulse signals. Okay, option D is correct answer. The maximum di by dt in SCR is, okay, now we know that V is equal to L into di by dt. We can write it as at maximum. Okay, now di by dt max is equal to Vs by L, or we can write it as root 2 into Vm by L. From this we can say that di by dt is directly proportional to peak voltage Vm and inversely proportional to L in the circuit. The only option which satisfies is option C. Okay, option C is correct answer.
Is a system defined by y of n equals to summation x of k from k is from minus infinite to n, where x of k is the causal signal. Then the system is an example of. Suppose x of k is the causal signal, means x of k is equals to non-zero for k greater than 0 or equal to 0, and equal to 0 for k less than 0. Okay, now here if we consider this summation for any n, suppose y of n naught means we can modify from the above definition. Y of n is k is 0 to n x of k, means for any value of n, it depends upon the past values of x of k. Hence y of n is nothing, this system is nothing but a memory system, it's not a memoryless system. So if we look into the, so it is what it is taking, depending upon the n, it is taking the sum of all the samples up to n, means it is not an averaging system, it is a summer. So hence option B and D are not correct. Comes to invertibility, see, we can write y of n as convolution of x of n into u of n, yes or no? So the z transform of y of n is nothing but x of z 1 minus z inverse. So it is invertible system, because if we multiply, the h of z is nothing but 1 by 1 minus z inverse. So we can get x of z by multiplying y of z into 1 minus z inverse, then we will get x of z back. So this system is an invertible system, hence option A is correct.